Okay, I want to talk about how you draw the electric field configuration, or sorry, the field line configuration for two charges. You could have as many charges as you want, by the way, but let's say we have two charges, and I'll have them be of different sizes. So a dipole would be two charges of the same size, but what if I had two charges of different sizes? So let's say that this one was, plus 5, and this one was minus 3 microcoulombs. And I want to show what the electric field lines are going to look like for this configuration, which is not a dipole. From a distance, it'll look like if you could just kind of compress these two to one charge, it would look like a plus 2 microcoulomb charge from a distance. So if I were to back up from really far, it should look something like that. And we'll get to that in a minute, but close up, what's it going to look like? So what I will do is I need to define how many field lines are associated with each microcoulomb of charge. So I'm going to just say somewhere, assume 1 microcoulomb of charge corresponds to 2 field lines. It could be whatever I want it to be. I could have it be 10 field lines. But that would mean that this one here would have 50 field lines leaving it, and that this one here would have 30 field lines coming towards it. And that would be more than I'd want to draw. So I'm arbitrarily picking this number, that each microcoulomb of charge is associated with 2 field lines. Whether it's positive or negative charge, that just affects the direction of the field lines. So I'm going to have, this one here then is going to have 10 field lines. Whoop, didn't mean to erase that. This one is going to have 10 field lines leaving it, and this one is going to have 6 field lines coming towards it. So how could I draw that? Well, the field lines always begin on a positive charge, and they always end on a negative charge. So if I were to put a positive charge anywhere on this line joining these two here, it would experience a force towards the minus 3 microcoulomb charge and away from the plus 5 microcoulomb charge. So I automatically have a field line that's going to look something like that. All right, I need to put 9 more on the plus 5 microcoulomb charge to satisfy what I am supposed to have here. So I'll have another one that's going to be, from here, it's going to be really repelled strongly by the plus 5 microcoulomb charge and then attracted to the minus 3 microcoulomb charge, something like that. So it looks kind of like a dipole looked. And then I'll have something that does something like this, probably. Should be symmetric. I'm going to try to fix that. Okay. So that's, now I've accounted for 5 of them coming out of this one. Now I have to get the other 5, because I need to have a total of 10. So I'm going to keep going here. I have, whoop, that's still an eraser. So I'm still going to have another one there, another one there, another one there, another one there, and another one there. And I've gotten all 10 coming out of there. But I still need one more coming into here. And I'm going to have that one be like this. Okay, so now this one has 6 field lines going into it. This one has 10. This one over here has 10 field lines leaving it. You can imagine that this field line right here is going to keep going all the way around the universe, and it's going to end up coming over to there, to this one here. So this, in a sense, is this one over here on the right is the same as that one over there on the left. So this is a nice way to express the field line configuration between two charges of different sizes. Plus 5 on the right, minus 3 on the left. And if, as I said earlier, let's say I back out here and I go really far away, you can imagine that this is a 2 microcoulomb charge here. So it's a lot like what I would have had if I had a plus 2 microcoulomb charge from a distance. It should look something like that. It should have, let me make it consistent with the one I just did. So I'm going to have something like this, something like that, like that. There's the 5. Let's see, I said 2 field lines per. So I actually have 1 too many. Let me clean that up. I'll make them symmetric. Because from a distance, even though it's a little hard to tell from how I drew the one over here, there should be a net total of 4 field lines leaving this region. And over here you see, if I come back here, you see that I have, it looks like I have 5 leaving. Here's one of them here, 2, 3, 4, 5, but I also have 1 coming in. And so my net is that I actually have 4 leaving, which is the case here. So this case here is kind of like a distant view if I were to back up really far from this one here. If I back up, it looked like I have a +2 microcoulomb charge, and eventually it should have 4 field lines leaving it, based upon my definition of 2 field lines per microcoulomb of charge. All right, so this is the approach you'll take. And you might even have some case, I'll give you another example here, of a configuration of where you don't know the size of the charge. What if I gave you something like this? Said, okay, there's 2 charges, and let me draw some field lines. Let's see. Let's say I had that. What would be a possibility of 2 charges that would result in that? Well, how I would approach that, I'd say, is that the one on the left has 3 lines entering it. The one on the right has 6 lines leaving it. So this one has to be twice the size of that one. So for instance, this one could have been a +2 microcoulomb charge. And this one could have been a -1 microcoulomb charge. Or this potentially could have been a +4 microcoulomb charge, and this one could have been a -2 microcoulomb of charge. These are all possibilities, as long as the one on the right is double the one on the left. I actually prefer this one because normally I assign an integral number of field lines per microcoulomb of charge. This one here would have been 1.5 field lines per microcoulomb of charge, which is, you could do, but it's a little unusual. Normally we say, for each microcoulomb of charge, let me assign an integer number. So in this case, it would be 3 lines of electric field lines for each microcoulomb of charge, and that would work out in this case. So you can have a configuration like that. And the last thing I want to show you is, what if you had 2 charges that had the same sign? They still have field lines associated with them. So what if they were both negative? So what that would mean, I'll make them the same size here. Let's just say they're both -2 microcoulombs. And I would have something like this that would be happening. I'd have field lines approaching them. From elsewhere. So if I put them together, I actually have a net of -4 microcoulombs of charge. So from a distance, according to this one, I have 2 lines per microcoulomb of charge. 2 Efield lines, I should say. Per microcoulomb of charge. And from a distance, that would be consistent with having this situation of a -4 microcoulomb of charge and 8 field lines coming towards it. Okay, Okay, so this situation is the close-up view, and this is the far-away view of it. But you can see that this kind of makes sense here. If you have a positive charge right here, it's going to be pulled by this one a bit, but it's going to be more pulled by this one. But the combination of the two is going to make that field line there curved, just like they're curved in the other cases for very good physical reasons. Okay? And then I believe in the PHET online system, colorado.edu, you will find an electric field line simulator where you can actually put charges there and see what the field line patterns look like. But this is conceptually how to do that. And on the next exam 2, this is as far as I'll get, is having you draw electric field line patterns or infer what charges are associated with a given electric field line pattern. Just like we showed in this example right here. Okay, that's it for electric field line patterns. Please do the activity on Padlet, where I ask you to construct electric field line pattern for a couple of charges, and write any questions you have about electric field lines on there. And that'll be your activity for Tuesday's class. And remember, I won't be there this Tuesday. Okay, good luck with this.